All right, let's see. 13.1, 13.4, 13.7. Oh, hey there, guys. So I am using this resource from our online curriculum, one of the pieces here, and I'm going to enter this table into a spreadsheet so that I can let, Google Sheets do the job that I want for the function. So one thing I did is I typed in all the numbers for the P column, and I'm going to go ahead and let's see a little bit of formatting for niceness sake. I am looking at how the 5, 0, 5, 10, 15, I wanted to show you that one thing we can do is if we select 0, 5, and 10. Let's see, what do I notice? Is it jumping by 5s, 5, 10, 15? Yeah, it is. Okay. So since it's jumping by 5, 10, 15, if we are then going from 0 to 75, we want the Excel file to show that work, right? So highlighted 0 through 5, and then I'm looking for that blue square, which I drag down to match, and it does. It matches. 0 goes by 5s. If I drag down 10s, it just repeats the 10s. So just a reminder that when you do this, that you need to select at least 2. It helps if you select 3. That way the pattern is there and you can drag it down. Okay. So yeah, we have 0 to 5, 0 to 75. We've got our p-values, depth of the pool from 0 feet out to 75 feet. And in this moment, let's see, we're doing a trapezoidal rule. If you remember the notes, if you remember our conversation from previous, maybe in the green book when we talked about this one, the trapezoidal rule from 6.5, it tells us that we can create trapezoids. See that? We can create trapezoids by breaking apart the intervals. And then, well, let's see, we're going to line up, figure out our delta x, and then we're going to line it up with our y value. So here our delta x is 5, and there might be a formula we would want to know in order to calculate 5 for our delta x, but we can just see 0, 5, 10, 15, 20. So trapezoid area is base 1 plus base 2, right? You take the edge of 1, you add it to another, and then you multiply that by our height divided by 2. In this case, delta x is our height. So clicking on E2, clicking on E2, that is our height divided by 2. And then in order to find the area of what's left, use parentheses, and I clicked on 5, and then I'm going to add to that. So clicking on the 5, that's cell B2. Then I'm going to add to that 2 times the sum of B3 to B16. That's all of the middles, right? Remember the singletons on the outside, the B2 and the B17. Those, using the resources that we have, we only add one of those. Those are the only times that a line is shared just one time. But adding them all up, we get 806.25. Wait, no, what? What was the problem? Wasn't there? Let's go back and look at the original integral. So, there it is. There's a 36. There's a 36 involved. For whatever reason, maybe that's 36 wide. Yeah, that's probably what it is. The pool is 36 feet wide, and then all of those depths mean that we need to multiply 36 times, just click on it. There we go, 806.25. So our trapezoidal estimate for the volume of the pool is 29,025 cubic feet. Here, I'll let you see the formula there. I hope it's coming through well enough for you. But yeah, there you go. You have it. You have the middles. All of these middles, they're actually results that are used twice in the trapezoid formula and trapezoid rule. And then singletons on the outside. So, yep, type it in, 29,025. Let me check it. That should be right. That's gallons, 29,000 gallons. That's a little bit of a real-world number sense check for you, right? 806 cubic feet is roughly 806 gallons. I mean, not perfect, but close. And so that's not really that much water in a pool. But if we go 29,000, yeah, now we're starting to get into some real-world territory. Good job. I'm going to leave this question up here for a minute because I wanted to let you know about one other trick that we could do. If you calculate in LRAM, it's relatively easy to do. We've got it in several other places in our sheet. We need to know the delta x. Cool. Click on it. We're going to sum up the depths from everything from the beginning up to almost the end. Almost. And we get, no, that's not right. Multiply by 36. There we go. So we have a 28,242 as our estimate. And I'm guessing that's actually a lower estimate. We'll see if the RRAM is a little higher. So delta x, click on the 5. We want the sum. This time we're going to skip the first number, and we're going to go from 7.2 all the way to the end. And don't forget the close parentheses. Oh, yep. Multiply by 36. Okay. So when we multiply by 36, we get 29,808. That's higher than our estimate. You want to know a trick, though? Take your LRAM plus your RRAM and average them. The average left and right Riemann approximation produces, let's see, click there, use parentheses, divide by 2. Yup. Oh my gosh, 29,025. They're exactly the same. So a shortcut for us could be actually calculating it all the way out, or we just do a left Riemann approximation and a right one. Thanks for watching this video.